Welcome to the first VMK in the OpenGL Tips and Tricks series. In the next set of VMKs, I'm going to show you how to work with sprites. A sprite, by definition, is just an area on the screen that represents an image. You usually associate a transparency with the texture so that your object or your sprite is not a perfect square or rectangle. Instead, it can be any shape you like. We'll be loading in square textures into OpenGL, but we can choose what dimensions we want to have our sprite represent. So it doesn't have to be a perfect square. It could be a tall or wide rectangle, and then by using transparencies, we can knock out the borders of that rectangle and make the shape of the sprite any shape we want. Now usually when working in sprites, you'll work in 2D, and in this VMK I'll show you how to use sprites in 2D using the OpenGL game engine developed on the website. You can, however, use sprites in 3D, but now things get a little bit tricky, because what can happen is if you render a rectangle on the screen, the user could theoretically walk in behind the sprite and it would disappear. So there's different kinds of tricks to fix this. You can do things like billboarding, where you always make the sprite face the camera or face the screen so that it will always appear it's perfectly square to you. And I'll talk about billboarding in a later set of VMKs in this series. But for now, let's get started with getting sprites rendered on the screen. To begin, I'm going to use this game engine source code from the website. You can get the source code either through the game development DVD, or you can purchase it directly through the store as well. I'm going to take the source code here and just extract it into a separate folder. And I'll rename this folder Sprites. I'm going to make a few modifications in this game engine, mainly cutting pieces out that we don't need. So I'll be deleting the testing.lvl file. Let's go into the resources folder, and in here under fonts we can delete the fancy fonts. We won't be using those. Under models we don't have anything, so let's delete that. And under textures we have GUI and crate. We're not going to be using either of these, so let's go and delete them both. In this VMK, I'm going to create a very simple scene that has a snowy background. In the foreground, what I want to do is use sprites to represent the snowflakes. So I'll use sprites to render snowflakes falling down on the screen. To get the background image, I just went online, typed in snow, and I found this snowman and pretty girl wallpaper, so I downloaded it, and I took this image into Photoshop and just changed the scale of it so that it's 1024 by 1024. Remember, our game engine always loads in square textures, and this image as it was not square, so I just needed to add in some extra space at the top here so that it fills up the image space to be exactly 1024 by 1024. Alright, so let's take that texture and I'll paste it here into resources texture called snow.tj, and this TJ file is going to be available to you with this VMK, so you can use it as well, or you can go ahead and create your own. Alright, let's open up our C++ code inside of Visual Studio. So here we are inside of our folder. Let's open up Sprites and Game Engine. I'm going to modify the game engine slightly so that it only runs in 2 dimensions. And we already have it sort of set up to do this because the GUI that initially loads up, that's all done in 2D. Only when you press on the play button do we actually transition into perspective mode so that we can render things in 3D. But until then, we're always rendering things just in ortho projection view. Let's go inside of our game OpenGL class. And inside of here under the, I think it was frame, we have this case structure here that specifies how we want to run our game every frame. And what I'm going to do is I'm going to comment all this out and only leave this one case statement, game state menu. So I'm basically going to be forcing our game engine to only run in this one game state. Now the other thing we need to do is, I think it was inside of the constructor, we set up our initial states here to start off in game state menu and then go into game state starting. So I'm going to delete this line of code so that we're only ever going to be inside a game state menu. Now we can go back inside of frame. Let's take a look at show menu, see what we do inside of here. We set up the background color to be black, and then we clear the buffer, we set our ortho projection matrix, turn on blending, we render our GUI, and then we render our console. We're not going to have a console, so let's comment that out. And we're not going to be rendering a custom cursor, so let's comment that out. And then finally we turn blending off down here. We are going to be using our own cursor, so we need to turn that on, which is inside of, I think it was the create function. If we scroll down to the very bottom, we have, no, it's not here. It must be inside of initialize maybe. Yeah, here it is. Hide the cursor. So let's comment this out, which will prevent our regular cursor from hiding. Now we'll always be able to see the Windows cursor. Let's save this, compile it, and see what happens. Precompiled headers cannot be found. Right. What we need to do is just do a clean build. So clean the solution. And the other thing we should also do is go inside of here under properties and make sure that under debugging we are setting up to be in our correct working path, which should be _build. Alright, now let's try compiling our program. We're probably going to get a few more errors inside of the scene class, but we'll go and clean those up in a second. Oh, we didn't get any errors in the scene class, but we should go and clean them up because our program will probably crash if we try to run it right away. So under the scene class, let's go inside of the initialize function. And inside of here, we're trying to load the small font. That's okay because I left that. The fancy font I deleted, so let's delete this part. And down here, we're loading the GUI texture. We no longer have GUI.tga. But instead we have snow.tga. So let's take this and type it in snow.tga. So our GUI_texture ID is now going to represent our background image. All this other stuff we're not going to use, so I'm just going to go ahead and return right here. We need a Boolean value, so let's just type in true to say everything's okay, and we're not going to execute anything beyond that. Alright, compile that and give it a run and see what happens. Oh, fancy ID is undefined. Right. Because I removed the code up here that referred to the fancy ID, instead of just returning, I'm actually going to have to comment all this code out so that it doesn't want to look for it. Okay, here's the bottom. Now let's try recompiling. Okay, and let's give this a run. Okay, so we have a black screen and just our regular cursor that shows up. Let's also change the title bar. Instead of physics engine, we'll have sprites or something like that. That was set inside of our main, I do believe. Yeah, right here. Let's just change this to be OpenGL tips and tricks. Okay, to get our image of the background rendering on the screen, we need to go inside of our scene class, and we're calling GUI render, so this is what gets called whenever we want to render something. And because we haven't loaded any controls into our game engine, we're not displaying anything. I'm going to comment out all of this stuff since we're not going to be using it. And instead, let's just write the following code. At the top here, we set up our model view matrix. We load it up with the identity matrix, and we also enable textures. I'm binding to the one texture that we loaded into memory, so this is our background texture. And I'm going to render a quad on the screen. I'm going to set the quad up to have a white background, and then I'm specifying the texture coordinates and vertex coordinates for all four corners of this quad. So starting at the bottom left-hand corner, moving across to the bottom right-hand corner, then top right-hand corner, and then top left-hand corner. You'll notice here that I'm specifying the vertex coordinates in pixels. Our texture is actually 1024 by 768 because it was a wallpaper, and I put it inside of a larger image which was 1024 by 1024. So the texture coordinates are going to range from 0 to 1 in the x direction and from 0 to 0.749 blah 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 in the y direction. This factor here tells me how far up the texture I need to go to reach the maximum before that black part that I ended up putting inside of here to fill in this texture to make it 1024 by 1024. So doing that, oh, and don't forget at the bottom here, also add in GL disable GL texture 2D because you've enabled textures up above after you've finished working with them, just disable them so you're not using them anymore. Okay, let's go and run this now. And we can see we have our image with the figure showing up inside of our window. Our window is a little bit small here because this window is actually rendered to be 800 by 600. So let's also change that inside of our settings. I think that was set inside of, possibly inside of the main. We're getting the width and the height resolution from our user settings. So let's go inside of here and change the defaults so that they're 1024 by 768. So right here we've specified 800 by 600. We'll change this to be 1024 by 768, and that should make our image a little bit larger on the screen, or at least it'll make our window larger as well. So there we go. We've got the full image now filling up our space. Some of it is getting clipped off by my video recording software, but that's okay. You should be able to see all the way past the feet of this figure here. Now I'm going to start adding sprites into the scene. Again, a sprite is just a portion of an image that you'll render on top of existing images. You use this in 2D games a lot, especially in the olden days whenever games were created for the Atari or the Commodore 64, things like that. There, you would load in a large image that had little pieces inside it. And each of those pieces inside of the larger image would be a smaller texture that represents different kinds of things, maybe like an icon of a bullet, an icon of some object you can pick up, another icon of maybe your figure looking left, an icon of your figure looking right. So what you could do is you can pick and choose which of those objects you wanted to render, and then you just render them on top of the static background. I'm going to show you how to do the same sort of thing using snowflakes in this video. Okay, I just closed off user settings.cpp and user settings.h. We won't need those. Let's also close off main.cpp, leaving us with just the scene. We can close this guy off as well. Okay, so we're rendering the background. Now let's go and create a function that can draw a snowflake so that you can specify an x coordinate and a y coordinate, and a snowflake will be drawn at this position on the screen. Now before we can draw a snowflake though, we need an image of a snowflake so we have something to draw. What I've done is I've gone into Photoshop and I've taken this image, and in the top left hand corner I've placed an image of a snowflake. Now if we zoom in here and take a look at this snowflake, you'll notice that it's a blue snowflake with a black background. However, this black background will not actually show up when I render the snowflake because I've gone ahead and added an alpha channel which goes and cuts the snowflake out. If I just look at the alpha channel, you'll notice that the white part is the part that will be visible when I render. The black part is going to be invisible when I render the snowflake. So as I render this, you won't be able to see the black background around the snowflake. And this is very important to do because when you're using sprites, as you have sprites overlapping one another, or when you draw sprites on top of the background, for instance, you don't want to be able to see a rectangular border that's surrounding your actual sprite. This snowflake here is going to represent our sprite that we're going to be rendering on the screen. Going back inside of our code here, I have a function called drawSnowflake, and we need to write this function. I could go ahead into the scene class and write a function called drawSnowflake, but I'm just trying to do this quickly, so I'm just going to write a global function here called drawSnowflake that renders our snowflake to the screen. All it's going to do is it's going to draw a quad. I'm specifying the texture coordinates and the vertex coordinates of this quad, and that's basically it. Now the quad itself is generated using these x and y values here. As you can see, the bottom left-hand coordinate is x, and then the bottom right-hand coordinate is fx plus 47. Our snowflake is actually 48 pixels wide, so I'm adding 47 to the original coordinate here. And then our y coordinate is given here, and then we offset it by 47 as well to go upward to the top right-hand corner. And here I'm adding 47 again. So our snowflake is really 48 by 48 pixels in size, located in the top left-hand corner of our image. Here's our code to render our snowflake, and we basically call this function to render it to the screen. Let's go and compile this and see what happens when we give it a run. Well, there we go. We have our image being rendered, and we're getting this white square showing up instead of our snowflake. So there seems to be something wrong. Let's go take a look at our code. Oh, I placed my render function here below disabling the texture. So I've actually disabled the texture and then tried to draw the snowflake, but the snowflake depends on having this texture enabled. So I need to place the draw snowflake command above GL disable. Let's give this a try. Okay, so there we go. We can see that there's now a snowflake above the snowman's head. So that's basically it. That's as easy as it gets to draw sprites on the screen. You just specify some coordinates that represent your texture and some coordinates to where you want to place that image on the screen, and then render your sprite to the screen. We're going to clean this up in the following VMKs, but let me show you one other thing we can do here very quickly. Let's say instead of drawing one snowflake, we wanted to draw a bunch of snowflakes on the screen, so maybe it looks like it's snowing. Well, to do that, what we can do is go inside of our scene class and create a variable that's going to hold all the information about each individual snowflake. I'm just going to scroll down here under the member section. At the very bottom, let's add in the following: std vector of vector3s, and I'm going to call it m_v snow. So it's going to be a vector of snow objects. Now, I'm using a vector3 to represent these snow objects. It's not going to represent a three-dimensional position. Instead, I'm going to represent a two-dimensional position, x and y, and the third component inside of this vector is going to represent the speed at which this specific snowflake is falling. Let's go and initialize our snow inside of our scene initialize function. Right before we return, let's do the following. I have a for loop here that's going to loop through 10 times, so I'm going to create 10 random snowflakes. Each snowflake I'm going to position somewhere on the screen. Horizontally, I'm going to choose a random value between 10 and 1,000, and in the y-coordinate, I'm going to choose a random value between 0 and 768. So this guarantees that all my snowflakes will be somewhere on the screen. The last parameter is the speed at which the snowflake is going to fall. So I'm specifying here some random value between 1 and 5, but then I multiply it by 0.5. So really, I'm getting a random value between 0.5 and 2.5. After I generate each of these vector3s, I then push them into this std vector so that I have the information saved for me. Now when I go and render, all I need to do is update the snow and then render it on the screen. So down here, instead of calling draw snowflake, we need to create a for loop that looks something like this. What I'm doing is I'm taking the y-coordinate of each of the snowflakes as I'm looping through here, and I'm subtracting its current value in the y by whatever value we stored here in the z component. Remember, the z component represents the speed at which the snowflake is falling. Now I go and call draw snowflake on the specific snowflake's x-coordinate and y-coordinate. So this snowflake is now going to be falling downward. Let's go compile this and see what happens. Notice we have a bunch of snow and it's starting to fall. And as it's falling, they all have different speeds because I randomly generated them. But notice that after they fall off the screen, no other new snowflakes appear. So I started off with 10, but 9 of them have disappeared and I only have 1 left, and it's about to disappear as well. So to make this a little bit more interesting, what I can do is continually regenerate the snow so that as a snowflake falls off the screen, then I randomly generate a new snowflake that appears above the screen, and it'll start to fall as well. To do that, we could add in the following if statement. After we update the y-coordinate here, we check to see what is its value. If its value is less than 50, then I want to say, okay, that's far enough down that I'm not going to be able to see it, or that's far enough down that it's hit the ground already, so I want this one to disappear, and I want to replace it with a new one that's above the screen. This new one is going to have an x-coordinate randomly generated, again, between 10 and 1,000. The y-coordinate is going to be 768, so it's at the very top of the screen, and it's also going to have a new z component, so it's going to have a new speed at which it falls at. And the rest of the code is the same. Now let's go and run this and see what happens. So now we have 10 snowflakes on the screen, and we always have 10. As some snowflakes disappear, the new ones appear from the top. And they're all different speeds, so you can see some of them are falling faster, some of them are falling slower. Now with this code that I just implemented, the snow is only falling downward because we only are changing the Y component. If you wanted to create like a blizzard or some other kinds of effects, you could change the way that these snowflakes fall. Instead of coming straight down, you can make them come down on an angle, or you can make them spin and twist as they're falling as well. You can do a lot with sprites. Hope you've learned something in this VMK to see how you can use sprites to enhance a visual effect on the screen. Come back for the next VMK where I'll show you how to take your sprites and actually create a sprite class which will do a lot of the work for you. Right now we're explicitly doing the work of each sprite, but by creating a sprite class we can encapsulate the work that a sprite has to do so that we can just call sprite render and then it will automatically update its position and render it on the screen as well. So I hope you come back for that.